In this demo, we're going to add a dataset to a pipeline in the Azure Machine Learning Studio ML Designer. To do that, we're going to create a pipeline and then add a Microsoft sample dataset to the pipeline. We'll know it's working once we can see the dataset on the designer canvas. Now, before we begin, you'll need to make sure that you have access to an Azure account. If you don't, you can create one for free at azure.microsoft.com/free. And with your Azure account, you'll need to make sure that you have access to an Azure Machine Learning workspace so that you can access the ML Studio. You'll also need to make sure that you have a compute cluster to attach that pipeline to. I would also recommend that if you're doing all of this using temporary resources, then put the Machine Learning workspace into its own Azure resource group. That way, when you're done going through these demos, you can delete the entire resource group and unload all the resources you created along the way. And that should save you ongoing costs and make things a lot easier for you. Okay, so the first thing we need to do is navigate to the ML Studio in the Azure portal in our browser. Excellent. Now that we're in the ML Studio, what we want to do is create a pipeline. So to do that, let's go over to the Pipeline Designer screen by clicking on the Designer option under the Author section. Good. The Designer page shows us all of the pipelines that we've got in the system, and from this screen we can add, edit, delete, and otherwise manage our pipelines. In our case, we want to create a pipeline. So let's click on the big plus button called Easy to Use Pre-Built Modules at the top of the page. As the Designer opens up for our new pipeline, we're asked to provide a draft name in the middle of the Settings pane. And if the Settings pane doesn't open, then click on the little cog icon next to the pipeline name at the top of the screen. So let's go ahead and give our pipeline draft a name. I'm going to name mine SB Test Pipeline Regression. Oh, and while you type out your name, notice that the name appears at the top of the screen too. Right at the top of the Settings pane, we're also asked to select a compute target. Now, if you don't have a compute cluster to use as the compute target, you can go ahead and create one via the Compute section in the Options panel on the left. Actually, you can even create a compute cluster on the fly when you go to select a compute target right here. But creating a compute cluster can sometimes take a while, so it's best to create it ahead of time. Anyway, in my case, I already have a compute cluster, so I'm just going to go ahead and select it. I can do that by clicking on the Select Compute Target link at the top of the pane. Now in the pop-up, you can select your desired compute cluster and then click on the Save button at the bottom. I'm going to select my SB Test Comp C compute cluster. Good. Now that we've set up our pipeline, the next thing we want to do is bring in a dataset to use. A dataset is basically a set of data that can be used to generate a model and train AI. You can create datasets pretty easily through the Datasets option on the left-hand Options panel. Datasets can be linked to online datasets, your own storage accounts, SQL, and more. In our case, we're going to make our lives a little easier here, and we're going to use a sample from Microsoft. So the first thing we're going to do is expand the Sample Datasets section in the Assets panel so that we can see all the sample dataset modules. Now in this list, we can see all of Microsoft's sample datasets. This includes census datasets, customer relationship management datasets, flight information, movie data, including IMDb, and even weather data. In our case, we're going to play with the vehicle pricing data. So let's hover over the Automobile Price Data Raw module and select the Use Dataset option in the pop-up. Perfect. So now we see that the module has been added right in the middle of the canvas. I can drag the module around if I want to. Now also notice that when I click on the module, I have some extra information in the pane to the right. And this pane tells us the module's name, type, and description. So at this point, we have a pipeline with a sample dataset ready to go. If you don't have autosave turned on at the top of the screen, then go ahead and turn it on, or just click on the Save button. Either way, we're ready to take the next step. In this demo, we're going to take a look at the actual data features of our sample dataset that we added to our pipeline in Azure Machine Learning Studio ML Designer. To do that, we're going to edit our existing pipeline and then explore the actual data in our dataset. Okay, so the first thing we need to do is navigate to the ML Studio in the Azure portal in our browser. Now we want to take a look at the data in the sample dataset we added to our pipeline. So obviously we need to open up our pipeline draft. So to do that, let's go ahead and click on the Designer option in the left-hand options list. Now this shows us all of the pipelines that we have in the system. So again, from here we can add pipelines, edit existing pipelines, and even delete pipelines. And obviously in our case, we want to edit our pipeline. So let's go ahead and find your pipeline in the list and then click on its name and open up the designer for that pipeline. I'm going to go ahead and click on my SB test pipeline regression pipeline. Excellent. Now we can see our pipeline, and sure enough, the only module that we have in the pipeline canvas is the automobile price data raw sample dataset module that we added previously. Clearly, we can add as many modules as we want, but for now we're good with this dataset. What we're going to do in this demo is check out the actual sample data in our dataset module right from within the pipeline designer view. It's worth noting that you can do this with any dataset module, not just this particular sample. Alright, so let's explore the dataset. To do that, you need to first select the module. Good. And then you can right-click on it and select the Dataset Output option from the Visualize submenu. And if you're using a Mac, you can Control-click on the module to access the context menu. Also, it's worth noting that every module has a context menu just like this. They'll obviously have different options depending on the type of module, but this is generally how we'll access features for modules. Anyways, let's visualize that data. Right-click, Visualize, Dataset Output. Now in the pop-up, you'll see all of the data that's in the dataset, and from here you can see that there are 205 rows of data with 26 columns. Plus, if we scroll across the list, we can see there's quite a spread of data here about individual cars and all the way to their price. So this is a pretty good dataset to use. You'll also notice that there are little charts at the top of every listed column. And these charts act as a distribution histogram for the data that we see in the column. Now we're particularly interested in the price column. Over the course of these demos, we're going to create a model that predicts what the price of cars should be based on the other data in the dataset. Of course, you might be wondering why we do that when our dataset already has a price in it, but this price is only here to help train our model. What we're going to do is use all the data to predict a price and then use this actual number to determine how accurate our model is. Then we'll use the model that gets the most accurate results to predict the price for other cars in the future. Alright, so for now let's actually click on the price column. Notice that the right-hand side of the pop-up has updated with some additional information about the price data. This section now tells us the mean, the min, and the max, and the standard deviation, the data type, and more. At the bottom, we even see the same histogram but in expanded form. What's interesting here is that the bulk of the cars in this list are super cheap, and that seems intuitively obvious, doesn't it? I mean, in everyday life, there are only so many Ferraris, Lamborghinis, and McLarens, but there are tons of Jeeps and pickup trucks and Beetles. To see some contrast, let's go ahead and select the Normalized Losses column. Here, notice how many missing values there are. 41! Wow, out of 205! So why is this important? Well, remember that our goal at the end of this will be to predict the price value. The problem here is that with so many missing values, this column of data is not going to be terribly useful. That's actually a key point. AI is really useful, but the accuracy of AI is only as good as the data that trains it. Therefore, the more data you have, the better your model will be. So keep that in mind when you're generating datasets. The more data and the more verbose, the more accurate your model. Now, let's click on the stroke column. Notice that the values range from around 2 to around 4. That's not a tremendous amount of variance. Meanwhile, let's click on the horsepower column. Here, notice that there's a huge variance of numbers from around 50 to almost 300. So this is way more variant than the stroke data. But why is that important? Well, once again, remember that we're trying to predict a price with this data set. So that means that the other data in the data set is going to impact that prediction. So the more variance a column of data has, the more likely it is to impact the prediction. And in this case, it sort of makes intuitive sense that horsepower should play a role in that price, doesn't it? But now let's take a look at the little histograms for peak RPM and highway MPG. Notice that the histograms look more or less pretty similar, with the peaks being in the middle, and that would suggest that there's a correlation between these two columns of data. Now take a look at the data values. Notice how the peak RPM values are in the thousands and the highway MPG values are in the tens. The reason this is important is because the peak RPM values has a pretty large variance, and so model algorithms might establish an overdependence on that column of data, when really we know that it's not necessarily true. Of course, more data might train the model away from that over time, but another option is to normalize the data. If there's some data that could be scaled differently to reduce its perceived importance, then that would be the ideal thing to do. Okay, so this is our data set. We can see that it's pretty good and reasonably intuitive, but we also see that the data needs some cleansing. And that's exactly what we're going to do next. In this demo, we're going to cleanse some of our sample data set that we added to our pipeline in Azure Machine Learning Studio's ML Designer. To do that, we're going to edit our existing pipeline and attach a data transformer module that will remove an unwanted column from our existing dataset. Okay, so as usual, the first thing we need to do is navigate to our ML Studio in the Azure portal in our browser. Good. And of course, since we want to play with our dataset in our demo pipeline, we obviously need to go and open up our pipeline draft. And to do that, we're going to go ahead and click on the Designer option in the left-hand options list. Then we'll open up our pipeline draft by clicking on its name. Alright, so here we are in the Pipeline Designer for our pipeline, and we can see our dataset right here on the canvas. So we're ready to go. Alright, so you might recall from when we explored the dataset that there were some minor issues with the data. Specifically, we saw columns with missing data, and then some other columns that had data at a scale that we knew would adversely affect any prediction algorithm that we might try to run. So what we want to do here is add a transformer module to, well, transform the dataset. Our goal is to adjust the dataset to remove an unreliable column of data so that the dataset can be used more appropriately in a model experiment. So what we're going to do is we're going to add a transformer to our pipeline. So let's get to work. First, let's expand the data transformation list in the module list on the left of the designer. As you can see, there are quite a lot of different transformer modules. You can use these transformers to add rows, add columns, convert to CSV, edit metadata, join to other datasets, remove duplicates, split data, and more. But what we're interested in here is making sure that our dataset only includes columns that we care about. So let's scroll down to near the bottom of the list and find the Select Columns in Dataset transformer. Good. Now let's drag the Select Columns in Dataset module into the canvas underneath our dataset. Now alignment doesn't really matter, but I find it reads better to put it underneath. Good. Now let's connect the two modules by clicking on the Output dot at the bottom of our dataset and dragging down to the Input dot at the top of the Transformer module. Good. Now what that means is that the dataset is the input to the column selection transformer. Now what we want to do is configure which columns we care about. So to do that, we need to click on the transformer module itself to select it. Now on the right-hand side of the designer, we can see the settings pane for the module. The main thing we want to configure is the Select Columns list. To do that, let's go ahead and click on the Edit Column link right above that field. Now in the pop-up, we can now choose which columns we care about, and there are two ways to do that. You can do it by rules, or you can do it by name. And in our case, we want to be explicit, and so we're going to do this by name. So let's click on the By Name radio button at the top of the pop-up. Now here we see two lists. The first list shows us which columns exist in the dataset, and the second list shows us which ones we've decided that we care about. In actuality, we care about all of the columns except for one. So this isn't a list where we're removing columns, it's a list where we're choosing the ones that we care about. Remember when we explored the data and we saw that there was a ton of missing values in the normalized losses column? Well, we're using this transformer to eliminate that column from the dataset. So what we're going to do here is pick all of the columns except the normalized losses columns by clicking on the little plus button beside each of the columns. So let's do that. Good. And now we'll click Save. Perfect. So now we have our first transformation. What we've done here is we've augmented the sample dataset and removed the normalized losses column from that dataset because it has unreliable data. That means that the output of the Select Columns in Dataset module is a much more reliable dataset and doesn't include the normalized losses column. In this demo, we're going to continue to cleanse our sample dataset in our draft pipeline in Azure Machine Learning Studio's ML Designer. To do that, we're going to edit our existing pipeline and attach two more data transformer modules to our existing dataset so that we can deal with missing values and normalize some data. Okay, so as usual, the first thing we need to do is navigate to the ML Studio in the Azure portal in our browser. And of course, since we want to play with our dataset in our demo pipeline, we obviously need to go and open up our pipeline draft. And to do that, we're going to go ahead and click on the Designer option in the left-hand options list. And then we'll open up our pipeline draft by clicking on its name. Alright, so here we are on the pipeline designer for our canvas, and we can see our dataset right there on the canvas, along with our module that removed the unwanted column from the dataset. Good. Now we're ready to go. Alright, so once again, you might recall from when we explored the dataset, there were some minor issues with that data. Specifically, we saw columns with missing data, and some other columns that had data at a scale that we knew would adversely affect any prediction algorithm that we might try to run. So what we want to do here is add two transformer modules to deal with missing values and to bring relevant values to the same scale. Our intent here is to end up with a dataset that's valuable and reliable and that can be fed to a model experiment. So let's get to work. Now the first thing we need to do is deal with the rows of data that have missing values. Remember that our existing transformer has already removed a column that's unreliable, but it has left columns that sometimes have missing data. So the existing transformer removed a column, but now we're going to remove rows. So what we're going to do is add another transformer that deals with the columns that have missing data. So first, let's expand the data transformation list in the module list to the left of the designer. Now once again, we're presented with all the transformers that we can use, and what we want is a module that deals with missing data. So scroll up or down the list until you find the Clean Missing Data module. And now let's drag that module onto the canvas right below our Select Columns in Dataset module. Now once again, alignment doesn't really matter, but it does make things easier to read if you put it below the other module. Good. Now we want to connect the output of the Select Columns and Dataset module to the input of the Clean Missing Data module. We can do that by clicking on the output dot and dragging to the input dot, and this will mean that the results of the first transformer module are used as the input to our new module. Perfect. So obviously the purpose of this transformer is to cleanse the dataset so that we can deal with missing data. So let's go ahead and configure that module. To do that, we need to click on the module, and that will open up the properties for that module. Alright, now in the Properties pane on the right-hand side, we can see a field at the top where we can select the columns that we're interested in dealing with. So let's click on the Edit Columns link above that field. Good. Now, just like the previous module, we're going to choose columns by their name. So let's click on the By Name radio button at the top. And in the dataset that we have, there are 3 columns that are prone to missing data: bore, stroke, and horsepower. So let's add those columns from the left-hand list to the right-hand list by clicking on the little plus button beside the column names. Good, and now we'll click Save. Now in the Settings pane for the Clean Missing Data module, we're going to create a rule that's going to remove rows that have missing data in any one of those columns that we just selected. This means that the dataset that moves forward will always have complete data. So to do that, we're going to set the minimum missing value ratio field to 0 and the maximum missing value ratio to 1, which it already is. Now these fields are used to detect missing values, and those settings basically just say any missing value. Now we'll configure the Cleaning Mode field to remove entire row. Good. Now what this means is that we have a dataset that has removed an unneeded column and has now removed all rows that have data missing from columns that we care about. We're making progress. Finally, let's add one more transformer. This transformer will be used to normalize some of the data so that some columns that have large numbers and some columns that have small numbers will be normalized to the same scale so that those columns don't cause any bias in the model results. Now in the transformer list on the left, let's scroll down until we find the Normalize module and then drag that onto the canvas. Perfect. Now let's connect the left-hand output of the Clean Missing Data module to the input of the Normalize Data module. Alright, so obviously the purpose of this transformer is to normalize certain data in the dataset. So let's go ahead and configure that module. Now to do that, we need to click on the module that will open up the properties. Alright, now in the Properties pane on the right-hand side, let's set the transformation method field to min-max, and this will set all the columns that we care about to the same scale so that none of them look way bigger or smaller than the others. Next is the field where we can select the columns that we're interested in dealing with. So let's click on the Edit Column links above that field. Good. Now, just like the previous module, we're going to choose columns by their name. So let's click on the By Name radio button at the top. Now, in the dataset that we have, there are a few columns that we want to bring about to the same scale. So let's go ahead and choose those columns. Let's add symboling, wheelbase, length, width, height, curb weight, engine type, bore, stroke, compression ratio, horsepower, peak RPM, city MPG, and highway MPG. And now we can click Save. Perfect. So now we have a dataset that we've removed unwanted columns, removed unwanted rows, and normalized various data. Our dataset is now ready to be consumed. In this demo, we're going to execute our draft pipeline in Azure Machine Learning Studio ML Designer so that we can explore our transformed dataset. To do that, we're going to edit our existing pipeline and submit it to our compute cluster for processing. Then we'll explore the output dataset once the run is complete. Okay, so as usual, the first thing we need to do is navigate to ML Studio in the Azure portal in our browser. So what we want to do here is execute our dataset transformation. And since that transformation is defined in our demo pipeline, we obviously need to go and open up our pipeline draft. And to do that, we're going to go ahead and click on the designer option in the left-hand options list. And then we'll click on our pipeline draft by clicking on its name. Alright, so here we are in our pipeline designer for our pipeline, and we can see our dataset right there on the canvas along with our various transformation modules that augmented our dataset as we wanted. Now before we get started, let's do a quick recap of what we've done here so far. First, we added a sample dataset for Microsoft called Automobile Price Data Raw. And this dataset has lots of information about cars, including mechanical details as well as price. Now we spent a bit of time to explore that data, and we found that there was a column of data called Normalized Losses that was totally unreliable because there was a ton of rows that were missing data. And that spurred us to add a transformer called Select Columns in Dataset to the canvas. Now that transformer allows us to choose the columns from the input dataset that we care about. In this case, we chose to include every column except the Normalized Losses column. When we were exploring the data, we also noticed that there were other columns that were missing data too. And none were quite as bad as Normalized Losses, but we still know that missing data can hurt model experiments. And that spurred us to add a transformer called Clean Missing Data to the canvas. Then we made our updated dataset the input to that transformer. And the Clean Missing Data transformer allows us to choose columns from that input dataset for which we want to deal with missing data. In our case, we chose the bore, stroke, and horsepower columns and configured the transformer such that if any of those columns had missing data, the entire row was removed from the dataset. And lastly, when we were exploring the original dataset, we noticed that some values were really large and some were really small. And that meant that the large values would seem to have bigger variances and thus more important than the smaller values. And that spurred us to add a transformer called Normalized Data to the canvas. Then we made our even more updated dataset the input to that transformer. And the Normalized Data transformer allows us to choose columns from the input dataset for which we want to match scales. And this makes sure that the columns would appear to all have equal importance, at least from a scaling perspective. In our case, we chose a bunch of columns of data. Now in the end, our transformer configuration should be removing a column, removing rows, and then scaling data for some selected columns. What we want to do now is confirm that this is actually happening. Now to do that, we need to execute the pipeline. So to execute the pipeline, all we have to do is click on the Submit button at the top of the screen. So let's go ahead and do that. Now in the pop-up, we're asked to connect our pipeline run to an experiment. Since we don't have an existing experiment, let's choose to create one. To do that, select the Create New Radio button. Now let's give our experiment a name. In my case, I'm going to name my experiment SB Test Pipeline Regression Experiment. Perfect. Now let's click Submit at the bottom of the pop-up. Okay, so the submission process executes the pipeline against the compute cluster that we configured. Now this process may take some time to run as the cluster spins up and each module is executed. You'll see the status in the toolbar at the top right, and you'll also see as each module is executed. But regardless, it will take several minutes to run. So we'll need to wait for the process to complete. But don't worry, I won't make you wait the whole time. I'll fast forward a bit here so that you don't have to wait so long. Excellent! All of our modules have executed. We can see that each module is green and marked with a completed label. Now what we want to do is take a look at the output data and see if it was actually transformed like we asked it to be. To do that, we need to first click on the Normalize Data module. Then, in the Setting pane on the right-hand side, we need to click on the Outputs and Data tab if it's not already selected. At the very top of the tab, you'll see a dataset called Transformed Dataset. In that box, you'll see a small graph icon with the tooltip of Visualize. So let's go ahead and click on that. Now in the pop-up, we can now see the normalized data. And as we scroll through the list, you'll notice that the normalized losses column is not there, and that a bunch of the columns now have normalized data to the same reasonable scale between 0 and 1. Perfect. We can now confirm that we have a pipeline that takes a raw dataset and transforms it to readings that we can now deem to be valuable and useful to future model experiments. Great job! In this demo, we're going to split our dataset in our draft pipeline in Azure Machine Learning Studio ML Designer so that we can use some of our dataset to train a model and some of it to test a model. To do that, we're going to edit our existing pipeline and add a module that will split our dataset into 2 random sub-datasets. Okay, so as usual, the first thing we need to do is navigate to the ML Studio in the Azure portal in our browser. So what we're going to do here is edit our existing pipeline. So to do that, we're going to go ahead and click on the Designer option in the left-hand options list. And then we'll open our pipeline draft by clicking on its name. Alright, so here we are in our pipeline designer for our pipeline, and we can see our dataset right there on the canvas along with our various modules that have transformed the dataset to something that we can work with. Good, now we're ready to go. So what we're going to do here is we're going to want to split the dataset. The reason we want to do that is because we have only a single dataset to work from, and we want to feed some of the data to a model trainer and the rest of the data to a model tester. The reason we do that is because we want to train a model, but we don't want to give it the entire dataset that we have. Otherwise, if we try to test the model with the same dataset, then of course it will have predicted the correct results. So what we want to do is split the dataset that we have into 2 randomized sub-datasets. So let's go ahead and do that. The first thing we have to do is expand the data transformation section in the module list on the left-hand side. Now, as a recap, it's worth noting that there are quite a lot of different transformer modules that you can use listed in this section. With these transformers, you can add rows, add columns, convert to CSV, edit metadata, join to other datasets, remove duplicates, and more. But what we're interested in here is splitting our dataset so that we can use some of our dataset to train a model. So let's scroll down the list to the bottom and find the Split Data Transform. And now let's drag the Split Data module onto the canvas underneath our current set of modules. Now alignment really doesn't matter here, but I find it reads better to put it underneath what we're going to use as an input. Perfect. Now let's connect our transformed dataset to the splitter module by clicking on the left-hand side output of the normalized data module and dragging down to the input dot on top of our split data module. Good. Now what we've done here is added a single module that will take the input dataset and split it into 2 random sub-datasets. In fact, notice that there are 2 dots on the bottom of split data module. That tells us that the module has 2 outputs, and that's exactly what we expect to see in this case. The question is, what can we expect in each of the 2 datasets? Well, to answer that question, we actually have to manage the settings of the module. So let's click on the module and make sure that it's selected. Okay, now on the right-hand side, we have the configuration pane for the split data module. This pane lets us configure all sorts of different options for how we're going to split the data. In fact, right at the top, there's a splitting mode option which has 3 options: split rows, regular expression, and relative expression. The relative expression option is used whenever you want to split data logically based on some number column or a date-time field. For example, you could say something like split the data by dollar amounts less than 50,000. The regular expression option is used whenever you want to split the data logically based on some expression. For example, you could say something like, split the dataset where names are greater than O. And finally, the split rows option is used if you just want to split the data randomly into two parts. In fact, that's what we're going to do here. So let's leave the setting as the default split rows option. Now let's configure the fraction of rows in the first output dataset option to 0.75. What that's saying is that 75% of the dataset will go into the first output. Ultimately, that means we're going to feed 75% of the dataset into the model trainer. Next, let's configure the random seed option to 1, 2, 3. This isn't terribly important, it just can't be 0. The dataset is split randomly, so the internals of the module needs a starting point for the random number generation. This number is used to randomly select rows. Perfect. Now let's leave everything else as the defaults. And good. So what we have now is a dataset that's been configured to our liking, and now we've added a splitter so that we can take some of that data and feed it to a model trainer, and the rest of that data into a model tester. Now if you don't have autosave turned on for your designer, now's a good time to save. Good job. In this demo, we're going to implement a regression training module in our draft pipeline in Azure Machine Learning Studio's ML Designer so that we can use some of our dataset to train a model. To do that, we're going to edit our existing pipeline and add a model training module that will use our freshly split dataset. Alright, so as usual, the first thing we need to do is navigate to the ML Studio. Now what we want to do here is edit our existing pipeline, so to do that we're going to go ahead and click on the designer option in the left-hand options list. And then we'll open up our pipeline draft by clicking on its name. Alright, so here we are in our pipeline designer for our pipeline, and we can see our dataset right there on the canvas along with our various modules that have transformed and now split the dataset. And now we're ready to go. Our intent here is to implement a module that can take our dataset and train a model from that dataset. Ultimately, what we want to do is create a model that will accurately predict what the price of a car would be. So what we've done is created a nice dataset with good data and split that data into two parts. We're going to use some of that data to train a model to predict prices, and then we're going to feed the results of that training and the rest of our dataset into a model scoring module to see how good our model is at making predictions. So the first thing we have to do is add a module that trains up a model. So let's open the model training section in the asset list. In here, there are a few different model trainers, and it's worth looking into each of these because what your specific data is like may warrant a specific module. In our case, we're going to use the simple train model module, and let's grab that and drag it onto the canvas. Placing doesn't matter, but to make things a little more readable, I recommend dragging it underneath our splitter and slightly to the left. Perfect. Now let's connect the left output dot from our split data module to the right input dot on the train model. Good. Now what we've done here is added a model trainer that accepts the first output from our split dataset. The dots we connected are important. The left output dot from the split data module is the larger dataset that we set aside for training. Meanwhile, the right input dot on the train model module is the dataset input. But you'll notice that the train model module has a warning symbol on it, and that's because it needs extra information. In fact, it needs to know what to train. Well, remember that our goal is to predict the price value for cars, so we need to configure that module to predict that column of data. So let's configure that. First, click on the train model module to make sure that it's selected. In the configuration panel on the right, click on the Edit Column link above the Label column field. Now in the pop-up, select the column name Price. And now we'll click Save. Perfect. So now we have a model trainer ready to predict the price value, except there's one problem. We need to tell the trainer how to train the model. We gave the trainer a dataset by connecting to its dataset input dot, but now we need to give it an algorithm to use to train the model. Now, as I said, we're trying to predict the price value, and we know that that value is numeric. So the best algorithm that we can use to train this model is a regression algorithm. So what we're going to do is add that algorithm to the model trainer. First, expand the machine learning algorithms section in the asset list. Notice that there are many different types of algorithms that are available to use. I highly recommend exploring each one of these algorithms to see how they fit against your particular dataset. However, in our case, we're going to use the linear regression algorithm. So let's find that module and drag it onto the canvas. And as usual, placement doesn't matter, but for readability, I'm going to add it above the train model module. Perfect. Now let's connect the output dot from the regression module to the left input dot of the train model module. Good. Now what we've done here is we've set up a model trainer that accepts a training type, which is the linear regression, and a training dataset, which is our cleaned, normalized, and split automobile dataset. At this point, we could run the pipeline and a model would be trained against our dataset. But how do we know if the trained model is any good? Well, that's a great question. That's where the second part of our split data comes in. What we want to do next is add a module that will take the output of the trained model and run it against our remaining dataset to figure out how good it is at predicting a price. So let's go ahead and do that. First, expand the model scoring and evaluation section in the asset list. Now once again, there's a few different options available here for evaluating models. In our case, we're going to use the simple scoring module. So let's find the score model module and drag it onto the canvas. In my case, I'm going to put it right at the bottom for readability. Perfect. Now connect the output of the train model module to the left input of the score model module. The left input is the input for models. Next, let's connect the remaining output of the split data module to the right input of the score model module. The right input is for datasets. Excellent. So now we have a pipeline that cleans a sample dataset, uses part of it to train a model, and then uses the rest of it to confirm that training. So let's go ahead and test this in action. Make sure your pipeline is saved first. Now click on the Submit button at the top of the screen. In the pop-up, let's go ahead and use the existing experiment that we created earlier. The run will take some time, so let's let it go until it's done. And I'll fast forward through this so that you don't have to wait. Great. Now that the experiment is complete, we can view our model training score. To do that, go ahead and click on the Score Model module to select it. In the configuration panel on the right, make sure you're in the Outputs and Logs tab. Now under the Data Output section, click on the Visualize icon, the one that looks like a graph, on the scored dataset. Now in the pop-up, let's scroll all the way to the right. Now notice that there's a new column that's been added called Scored Labels. This column contains the predicted label values for the dataset that remained. In fact, we can see that there are 50 rows that were run against our trained model. Now we can compare the price and the scored labels column, and we can judge how close the values are. In some cases, the values are reasonably close, and in other cases, they just aren't. Regardless, we have a result, and now we can make tweaks if we need to. So great job! You now have a pipeline that is able to train a model and test the results. In this demo, we're going to train and test a classification model in a new pipeline in Azure Machine Learning Studio. To do that, we're going to set up a Microsoft sample dataset, and then we're going to create a whole new pipeline, add that dataset to it, normalize the dataset, and then apply logistic regression to the dataset to train a model. And then we'll score the model and evaluate the results. Okay, as usual, the first thing we need to do is navigate to the ML Studio in the Azure portal in our browser. Our intent with this demo is to train a classification model. For that, we need a dataset that includes information that can be classified. When we used the automobile dataset, it only included information about cars, but nothing really that can be classified per se. What we need here is data that we can use to make a determination about. So what we're going to do here is use the Microsoft Diabetes dataset, and then we're going to use that to predict which rows in the sample suggest that the person is diabetic. So the first thing we need to do is create a dataset that we can use for that classification. So first, click on the Datasets option in the left-hand menu. Now let's select to add a new dataset from an online source by clicking on the Create Dataset button and selecting the From Web Files option. Next, we're going to give the link to a Microsoft Online Diabetes dataset. We'll type the value out into the web URL field. The value to type out is https://aka.ms/diabetes-data. Good. Now let's give our dataset a name. I'm going to call mine SB-Test DSET Diabetes. Good. Now we'll leave the rest as defaults and click Next at the bottom of the screen. Next, in the Settings and Preview step, make sure to select Use Headers from First File in the Column Headers field. Then you can leave the rest as default and click Next. Alright, now in the Schema step we can leave the defaults and click Next one more time, and then click Create. Perfect. Now we have a dataset that we can play with when we train a classification model, and in fact that's what we're going to do next. In order to do that, we're going to create a totally new pipeline. So let's go ahead and click on the Designer option in the left-hand options list. Then we'll create a new pipeline by clicking on the big plus button at the top of the page. Now some of this we've done before, so I'm going to go through a little quicker this time. What I'm going to do is use the Pipeline Settings panel on the right and select my compute cluster and then name my pipeline draft SB-Test Pipeline Classification. Good. Now what we want to do is add our dataset. To do that, let's open up the Datasets section in the module list. Notice that our fancy dataset has found its way into the list. Alright, so let's drag that to the center of our canvas. Alright, so now we have Microsoft's raw diabetes dataset in our pipeline. The problem is that it's not exactly what we want. We want to make sure that the dataset is cleansed in preparation for our model. So what we're going to do is add a normalization step to make sure that the relevant data is all scaled the same. So let's go ahead and do that. First, we need to expand the Data Transformation section and scroll down to the Normalized Data module. Now we'll connect the output of the dataset to the input of the transformer. Good. Now we need to select which columns of information we want to normalize. To do that, we need to configure the normalizer. So click on the module and make sure that it's selected. And now in the right-hand configuration panel, let's select the min-max value in the transformation method field. And finally, we can select the columns. To do that, click on the Edit Column link above the Columns to Transform field. In the pop-up, we're going to want to choose columns by name, so click on the By Name radio button. Okay, so the columns that we want to select are pregnancies, plasma glucose, diastolic blood pressure, triceps thickness, serum insulin, BMI, diabetes pedigree, and age. So go ahead and move those columns like I've done and click on Save. Good. Now we have a dataset that's been normalized. Now we can finally start looking at training our model. But first, just like the regression demo, we need to split the dataset so that we can train the model with some of our data and test the model with the rest. So let's go ahead and add a split data transformer beneath the normalized data module. Good. Now let's connect the two. And now let's configure the split data module so that it splits rows at 75% with a random seed of 1, 2, 3. And good. Now we can add our model trainer. Now in the module list, open up the model training section and drag in a train model module. Now let's connect the left output of the split data module, the output that contains 75% of the data, and attach it to the right input of the train model module, the input that accepts a dataset. Good. Now you'll notice that the train model module has a little warning icon on it, and that's because we need to specify which column we want it to predict. In this case, we want our model to predict if an entry suggests the person is diabetic. So in the configuration panel for the train model module, select the diabetic column. Excellent. Now the diabetic column is a classification value. It's not numeric necessarily. The expected result is basically yes or no. In actuality, it's 1 or 0. So we want to give our model training module the proper algorithm to be able to perform a classification of that type. In this case, we want to add the to-class logistic regression module from the machine learning algorithms section in the asset list. So let's go ahead and do that and then connect it to our model trainer. And we're going to leave all of its settings as default. Perfect. Now this is taking shape. Now we have a dataset, a normalization transformer, and a model trainer with a proper algorithm. So just like with the regression demo, now we want our pipeline to score our model training. To do that, we'll add the score model module from the model scoring and evaluation section and connect the module with the remaining portion of the split dataset. Alright, so at this point we have a model that we can run an experiment on and take a look at the results for. But let's make this a little easier for ourselves and make our pipeline do that for us. What we're going to do is add an evaluation step. The evaluation will give us a bunch of information on our model result. To do that, drag the Evaluate Model module over from the Model Scoring and Evaluation section and connect the output of the Score Model module to the first input. Good. Now we can execute an experiment and see how this works. To do that, click on the Submit button in the top right. Now in the pop-up, let's go ahead and create a new experiment. I'm going to call mine SB Test Pipeline Classification Experiment. Now once you've got yours configured, go ahead and click on Submit. Now as usual, the run will take some time to execute, so I'm going to fast forward a bit here. Perfect. Our run is completed. Now let's go take a look at the results. Click on the Evaluate Model module to select it. Now in the Configuration panel, click on the Outputs and Logs tab if it's not already selected. Now click on the Visualization button, the one that looks like a graph on the Evaluation Results box in the top of the pane. Good. Now let's take a look at the confusion matrix for the model. Now this is very interesting. Remember that the objective is to predict the diabetic column of data. We know that the value is either 1, meaning diabetic, or 0, meaning not diabetic. In this case, we get a nice quartile split of data. We can see that the actual values, what was in our data set, along the top, and the predicted values, what our model predicted, along the side. And what we hope for is that the bulk of the predictions are accurate. So we hope to see that the bulk of the numbers will either be in the top left quarter or the bottom left quarter. The values in the top right or bottom left are misses, and this tells us that our model predicted something that didn't match our actual data. Now the wonderful thing about AI is that this doesn't necessarily mean that our model is good or bad. In fact, this could be an indicator that our data is bad. Perhaps some people have been misdiagnosed. Regardless, you can now see a model that works with data to classify it accordingly. In this demo, we're going to train and test a clustering model in a new pipeline in Azure Machine Learning Studio. To do that, we're going to use a Microsoft sample dataset, then we're going to create a whole new pipeline, add that dataset to it, normalize the dataset, and then apply clustering logic to train a clustering model. And then we'll assign that data to clusters. Okay, so as usual, the first thing we need to do is navigate to the ML Studio in the Azure portal in our browser. Now our intent with this demo is to train a clustering model. So for that, we need a dataset that includes information that can be clustered. When we use the automobile or diabetes dataset, we could cluster some of that dataset, but for this experiment, we're going to use data about penguins to do some clustering. In fact, to save time, I've already set up a dataset ahead of time from a Microsoft sample. The results of our experiment won't matter so much, but if you want to use the same dataset, you can find it at https://aka.ms/penguin-data. So as I said, what we want to do is create a pipeline that trains a model to cluster data together. In order to do that, we're going to want to create yet another new pipeline. So let's go ahead and click on the Designer option in the left-hand options list. Then we'll create a new pipeline by clicking on the big plus button on top of the page. Now some of this we've gone over before, so I'm going to go through it even quicker this time. What I'm going to do is use the Pipeline Settings panel on the right to select my compute cluster and then name my pipeline draft SB Test Pipeline Clustering. Good. Now what we want to do is add my Penguin dataset to the canvas. Alright, so now we have Microsoft's raw Penguin dataset in our pipeline. The problem is that it's not exactly what we want. We want to make sure that the dataset is cleansed in preparation for use in our model. So what we're going to do is choose some specific columns, clean up missing data, and then normalize the data. So let's go ahead and do that. Let's bring in the Select Columns in Dataset Data Transformation module and connect it to our dataset. Next, let's use the configuration panel for the module to select which columns we want to keep. Now in the pop-up, we're going to want to choose columns by name. So we're going to select the columns Kuhlmann length, Kuhlmann depth, flipper length, and body mass, and click Save. Perfect. Now let's bring in the clean missing data module and connect it to the module we just added. Perfect. Now once again, let's use the configuration panel to select which columns of information we want to check for missing data. Now in the pop-up, we're actually going to choose to use a rule this time. In fact, let's choose the All Columns rule in the selection and then click Save. Good. Now let's select the Remove Entire Row option from the Cleaning Mode field. Excellent. And finally, let's bring in the Normalize data module, connect it up, and then configure it to normalize all the columns again. Good. Now we have a data set, and we're only using the fields we want. We've removed any row that has missing data, and we've normalized all that data. Now we can finally start looking at training our model. But first, just like our other demos, we want to split the data set so that we can train the model with some of our data and test the model with the rest. So let's go ahead and bring in the Split Data Transformer module and configure it for the 75% split, just like we've done before. Good. Now we can add our model trainer. In the module list, open up the Model Training section and drag in the Train Clustering Model module. Now let's connect the left output of the split data module, the output that contains 75% of the data, and attach it to the right input of the train clustering model module, the input that accepts a dataset. Good. Now we need to configure the model training module a bit. If you click on the module, you'll notice that in the configuration panel that it requires a set of columns to cluster. So let's go ahead and configure that field. We'll want to cluster all of the columns, just like we did with the transformers. Perfect. Now what we want to do is apply an algorithm to the model training. And since we're trying to cluster data, we need a clustering algorithm. So let's grab the K-means clustering module from the Machine Learning Algorithms section of the module list and drag it into the canvas above our model trainer. And then let's connect the two modules. Now what this algorithm does is group items into whatever number of clusters you want. This is what the K means. So what we're going to do here is ask for our dataset to be logically grouped into 3 clusters. We can do that by selecting the module and then setting the number of centroids field to 3. So here's the thing, we don't actually know what the grouping is going to be. We're asking our model to look at this penguin dataset and try to figure out what a logical grouping would be if we wanted 3 separate groups. Maybe it'll decide to group them by flipper size, who knows? But now we're just about ready to find out. The last thing we want to do is put our remaining data from our split dataset into those clusters. To do that, we're going to drag the Asset Data to Clusters module from the Model Scoring and Evaluation section of the asset list onto the canvas and attach it to our model trainer and our dataset. Notice that the left output of the model trainer attaches to the left input, and the right output of the splitter attaches to the right input. Good. Now we can execute an experiment and see how this works. To do that, click on the Submit button in the top right. In the pop-up, let's go ahead and create a new experiment. I'm going to call mine SB Test Pipeline Clustering Experiment. Now, as usual, the run will take a long time to execute, so I'm going to fast forward a bit here. Perfect. Now our run is completed. So let's go take a look at the results. Click on the Assign Data to Clusters module and select it. Now in the Configuration panel, click on the Outputs and Logs tab if it's not already selected. Now click on the Visualization button, the one that looks like a graph on the Results Dataset box at the top of the pane. Good. Let's take a look at this dataset. Notice the Assignments column. This column shows that some rows have been put into cluster 0, 1, or 2. Obviously, we can analyze this data further to determine what sort of criteria warranted going into one cluster versus another, but that's not important right now. Ultimately, what is important is that we've been able to take a dataset and logically cluster information into various groups. Excellent. Finally, as we look back at this course, we can see that we've created pipelines that cleanse and normalize data, that split data for evaluation and testing purposes, that train models by regression, classification, and clustering, and that we can use to score and evaluate other datasets. Great job! So in this course, we've used the Azure Machine Learning Studio Designer to create and build a custom AI pipeline. And we did this by exploring using the ML Designer to create a dataset and use features, adding data transformations in ML Designer, normalizing, clearing data and viewing output of transformed datasets, manipulating data for training and validating a model, and using a regression, a classification, and a clustering model in ML Designer. In our next course, we'll use the Azure Machine Learning Studio scoring and evaluation metrics to evaluate and test a predictive